Hi guys, we are from Faculty of Electrical and Electronic Engineering. Course name is Calculus and the code is BEE 10103. We are from Group 7, Session 2, and our lecturer name is Wan Nur Hafsha binti Wan Khairuddin. And today we are going to present about how to solve engineering problem using MATLAB software involving the application of differentiation and integration principle. So my name is Muhammad Hafiz bin Muhammad Nazri. My matrix number is AE 2300 and 34.
And my name is Tom Kim Liao, and my number metric is AE230070.
And my name is Muhammad Sefakmal bin Muhammad Yusof. Number metric is AE230001. So from the task given, the question 1 is about figure out the changing rate of voltage across an inductor of inductance with the current flow I at t equal to 5 seconds, t equal to 10 seconds, and t equal to 15 seconds. It was given that the L equal to 5 H and current 0.2 minus 2 times A. Then we have to plot a graph that can show the voltage variation over time for each given time period on a single graph by using MATLAB software and compare the calculation result. We also need to write a discussion about the solved problem.
Next, in question 2, the problem is required to find out the voltage across capacitor in RC integrated circuit. After we find the V out, we just simply substitute the given value of R equals to 1 kilo ohm, C equals to 10 microfarad, and V input is 12 volt. But since the question mentioned that the capacitor was initially charged to 3 volt, then to calculate the V output, we need to subtract the initial voltage of the inductor to get the real voltage output across the capacitor.
So firstly, we extract out all of the information given from question 1, which is equal to 5. Then we differentiate the IT. By differentiate IT, this will show the result of the IT. And then since the current voltage across the inductor is V equal to L dIdt, then we set the formula as the instantaneous voltage. And then after the differential dIdt, we substitute the value L equal to 5 and the dIdt into the instantaneous voltage, and this should show the equation result for V equal to L dIdt. So and then after that we just simply substitute the time t equal to 5 seconds, 5s, t equal to 10 seconds, and t2 equal to 15 seconds, the v equal to L dIdt to determine the changing rate changing rate of voltage. This will show the result of a specific rate change of the voltage across inductor. So I will run the program. So this is the graph. Right. So for the question number 1, the answer of the IDT is negative 2 exponent negative 2 power of t. So the instantaneous voltage for 5 seconds is negative 9.0800 exponent negative 5. And then go through with the 10 second, this one, 15 second. So the voltage is the same. So the what we call the program and the manipulation get this answer. So it's okay.
Okay, hi guys. Today I'm going to explain to you guys about the graph for question 1. Firstly, to plot the graph of V against T by using MATLAB software, we set the time range from 0 to 35 seconds. And then we set the formula for calculating the volt at specific time. After that, we set the voltage T point for 5 seconds as color blue, 10 seconds as color yellow, and 50 seconds as color green. Then we set the title for the graph as voltage against time. Then we set the x-axis as time and y-axis as voltage. Lastly, hold on means we add a new graph. Then grid on means to display the grid line. And lastly, hold off means close the add graph function. I think that's all for me. Thank you.
Doctor and everyone. Now I will going to present about the question 2. Question 2 is about a RC integrated network. The question 2 want us to evaluate the voltage across the capacitor after 30 milliseconds when the RC integrator circuit combined with 1 kilo ohm, 10 microfarad, and the voltage input is 12 volt. Assume that the capacitor is initially charged to 3 volt. Now let us move to MATLAB for the solution. Firstly, we extract the information given from the question 2, which is the R equal to 1 kilo ohm and the capacitor equal to 10 microfarad and the voltage input equal to 12 volt and the time after capacitor is 30 milliseconds and the V initial is -3. Next, we declare the V out as the function by using this code SYMS V out T, and then we set the formula for this function as the 1 over RC integrate V input, and the lower limit is 0 and the upper limit is T. This should show the integrated equation for V output across the capacitor. And then we substitute the value T equals to 30 milliseconds into the integrated equation V output, and it should calculate the value for the voltage output across capacitor after 30 milliseconds. But we haven't done yet because the question 2 stated that the capacitor is initially charged to 3 volt. So we need to subtract the V initial to get the real voltage output across the capacitor after 30 milliseconds. So we use the voltage output that we calculated and minus the V initial. And this will show the real voltage output across the capacitor after 30 milliseconds. Let's run the program. So the integration result is 1200 T, and the voltage across the capacitor after 30 milliseconds before the capacitor is initially charged to 3 volt is 36 volt. If the capacitor is initially charged to 3 volt, the voltage output across the capacitor after 30 milliseconds is 33 volt. Thank you. That's all from us.